Hi there guys, my name's Lewis and today I'm going to be your youth tutor along with...
I'm Harry and I'm also going to be your youth tutor.
With a different sweatshirt, very nice.
Slightly different sweatshirt.
He's got a skeleton on the back of his sweatshirt. I don't have anything on the back of mine.
Oh, you're pure. Okay.
Today, Harry and I are going to be differentiating an inverse function. I'll quickly run through the question. Sand is poured onto the floor at a rate of 4 centimeters cubed per second and forms a cone where the height is 3/4 of the radius. And we've been asked to find the rate of change of the radius when r is equal to 4 centimeters. We've also been asked to leave your answer in terms of pi. We have already took the liberty of drawing a quick diagram of
That's a very
cone.
good diagram.
It's a very good diagram, and obviously we've put into the information here that we know from this little section, which is the height is 3/4 of the radius, so h is equal to 3/4 r.
Okay. Over to Harry.
So what we need to find is the rate of change of the radius, which we can write as dr dt. And we've also been given the rate at which the volume of sand is poured.
So we've got to find the RDT. Would you mind just
Yep.
putting find here, please? Thanks.
And dr dt will be equal to the volume, the rate of volume, so dv dt, times, we need to times it by something which will cancel to get us dr dt, so we need dr dv.
So you've used what rule there?
It's the chain rule.
Would you just put that on under the that very good diagram there, please?
Chain rule.
Yeah, the chain rule. So dy dx.
Oh.
Yeah, chain rule. And underneath that we want, can you just put the chain rule dy dx?
du dx.
dy du.
dy dx.
Put you on the spot a little bit there, Harry. Great, and this, what you've just done on the board, is using that rule. Okay.
Using that rule, but with our values of volume and the radius. So we know that dv dt is 4 centimeters cubed. So we could plug that in underneath.
4 centimeters cubed per second. Yeah.
Yeah. So we want to find dr dv, but what we can do using our equation of a cone over here is find dv dr. So to find that we want to differentiate.
How do you do that when you've got an h in there? Though?
Oh yeah.
Okay.
So in the question it gives us that the height is 3/4 of the radius. So if we plug that in we get a third pi 3/4 r cubed. And then we want to differentiate that. So we're going to do dv dr. So we're going to come across, so it's going to be pi 3/4 r squared.
Be careful there, Harry. Can you just the r squared? It looks like it could be 4r squared. Could you?
Yeah. If I write it out here as 3/4 pi r squared, that's a bit easier to see, and it's the same thing.
Yeah. You didn't tell us how you got 3/4 pi r squared. How do you do that?
So we're going to differentiate. So we're going to times a third by our power, which is just 1, and then we're going to take 1 away from our power.
And that leaves r squared.
Yeah.
Okay, that's great. Okay, so we've got an expression for dv dr now.
Yep, and now Lewis is going to come in and explain how we get dr dv.
Oh yeah, so we've got dv dr, so we need to invert it, yeah?
Yeah.
Okay, that's no problem.
Yeah.
So to invert this, oops, sorry, mate. You need to. So I'll just bring it over here, shall I?
Yeah.
So we want to find dr dv because that there is what we've got in this equation here. I'll make that be a little bit bigger. So to do that, we basically just need to put that. We just need to flip it essentially.
So it becomes 1 over, yeah.
So it becomes 1 over 3 over 4 pi r squared. And then from that we can then input this little bit of knowledge here.
Well, actually, can we just flip it so we get an expression without the 1 over, please, Lewis? So it's going to become 4 over 3.
Okay. So it'll be
4.
that there is the equivalent of, is it
4 over 3 pi r squared.
Yeah. So that equals 4 over 3 pi r squared.
Yeah.
Okay.
Yeah.
And then now we can put in that we know r is equal to 4 centimeters. So now we can put that in here as well. So that there becomes 4 over 3 pi times 4 squared. 4 squared is obviously 16. So we can put that in there now as well, which is equal to 4 over 3 pi times 16.
Yeah.
From that,
So we're just going to cancel out 4 and 16, or part of it, yeah. So it becomes 1 over 4.
yeah, so it goes
1.
1 over.
So this 4 and 16 we can cancel, divide by 4 top and bottom there.
Oh, okay, so that becomes 1
Over
over
3 pi times 4, yeah.
okay, 3 pi times 4, which is equal to 1 over 12 pi.
Yep. Well done. Okay, so now...
And then now you can put that, because now obviously, now we know that, I'll just put that in there, shall I?
Oops, coming back.
dr dv, so that there is equal to dr dv. So now
Equals
we
1
can,
over 12 pi.
so now we can put that into there.
Yep.
So therefore, that there is now dv dt times dr dv, which you obviously got down here, which is 1 over 12 pi. And then that basically just goes to 4 over 12 pi, and then you can obviously just go divide it down, simplify it, sorry, so it becomes 1 over 3 pi.
And what would the units of that be,
the
please?
units of that will be in centimetres per second.
So could you put at the bottom there just dr dt, please, equals that. So dr dt, so this is your final answer, yeah?
Yes, it is, yeah. Yeah, that's the final answer. Thank you guys for watching.
Do you agree with this, Harry?
Yeah, I agree.
You agree? You concur?
Yeah.
Well done, you two. That was absolutely great. Thanks very much.
Thank
Well
you
done.
guys.
Thank you.